Hello students, now we will entering into the unit 4, that is power converters. So name itself, we will discuss converting the power. So we have so many types of power converters. In this unit especially we are discussed about the DC converters, DC to DC converters. DC to DC converters means this DC power is converted into again DC power. That DC power, this high power converted into low power or low power converted into high power. The another name of this DC to DC converters is called as choppers. Chopper is the another name. Chopper is defined which converts fixed DC power to or DC to variable DC power. So we have fixed DC, there is no change of DC, but we can convert variable DC. That variable DC may be high DC or low DC. For example, we have a DC power, a DC voltage. For example, DC voltage is 5 volts. This 5 volts DC voltage is applied to chopper. This is the chopper. Then the output may be more than 5 volts, 8 volts, or we can get less than 5 volts. That means 3 volts. The output which is more than input voltage, the chopper is called step-up chopper. The output less than the input voltage is called step-down chopper. Understand? So that's why this chopper, we can name it as the chopper can be classified, divided into two types. One is step down chopper or step up, take it as a step down chopper. Another one is step up chopper. So name itself step down chopper, that means the output voltage is less than input voltage. That chopper is called as the step down chopper. The output voltage is more than the input voltage is called as the step up chopper. We have some relation between the output and input here. The relation is generally we will discuss in the next, but just you mind it. This is the types of choppers. First, what is DC to DC converter? DC to DC converter means the element, the device which is used to convert fixed DC to variable DC is known as the power converter. In this unit we will discuss to DC converter. The another name of DC to DC converter is the chopper. Generally chopper is two types. One is step down chopper, another one is the step up chopper. The output voltage less than the input voltage, the output quantity less than the input quantity is known as the step down. The output voltage is more than the input voltage, or another name, the output quantity, if it is more than the input quantity, then it is called the step up chopper. So in this he given, in the step down chopper he mentioned buck converter. The another name of the step down buck converter. In the syllabus he given the we have to study about the buck converter, and in the step up chopper so many types, but in the syllabus he given the boost chopper, buck converter or boost converter. So this is the boost converter. Examples we have more, but buck converter is nothing but the step down chopper, and boost converter is nothing but the step up chopper. So now we will discuss about this. First thing is the DC to DC buck converter. DC to DC buck converter. That means what it represents? This represents the output voltage must be less than the input voltage. So look at here. What is the input voltage here? The input voltage is, this is the input voltage. So this name, we can name it as the input voltage or input power. And what is this V0? V0 is the output voltage. V0 is the output voltage. This is input voltage and this is the output voltage. So in this DC to DC buck converter or step down chopper, these input voltages must be less than the output voltage. So how we will get, we have to discuss here. And first, in this construction of the DC to DC buck converter, we have to analyze each and every element. The first is the switch. First is the S is nothing but the S is represents the switch. Switch. What is the application of the switch generally? So it will be on, off will be done here. Switch is on, what happened? Input power flow to circuit or given circuit. But if off, input power doesn't flow to circuit. If it is closes, then the power will be entering into this circuit. If it is opens, there is no input power in the circuit. Okay, in these power electronic devices, we are using elements are IGBT and MOSFETs are used as the switches. IGBT or MOSFETs are very applicable. Very applicable. This is the about the switch. Next element is there, that is the diode. This is called as the D for diode. Diode is an unidirectional device. It's look like this, unidirectional device. Whenever we will give the forward bias. Forward bias means whenever we apply in the forward bias, positive side is this side and negative side is this side, it will be acts as the on switch. So if it is reverse bias, reverse bias means reversely applied. The reverse is positive side, this is positive side, then it will act as the off switch. This is called the on and it will act as the off. This is about the diode. Understand? Next, inductor. You know that L already you know the character of the inductor. When we are discussed about the study of the AC circuit, we discussed there. This is the inductor. Inductor, it opposes sudden changes in current. It opposes sudden changes in current. The current change will be slowly. Sudden changes in current. Okay, and so that is the property. Why? That's why we are using here. And we have the capacitor. It absorbs the high frequency magnitudes. If the frequency is more than the given frequency, high frequency harmonics. No. Harmonics means unwanted magnitudes in the circuit that can be observed by the frequency. Here the LC combination is there. this LC combination, this LC setup will be used as the filter. This is used as filter. This is used as the filter. Filter which eliminates the unwanted harmonics. Filter application is which eliminates the unwanted harmonics. Unwanted harmonics means unwanted magnitudes in the thing. Unwanted harmonics. These are the main elements in the converter. First is switch, second one is diode, third one is inductor, fourth one is capacitor. And this is the input voltage and this is the output voltage. The change in input voltage we will get at the output. Okay. And this DC to in order to understand this operation, it can operate in two modes. The first mode is if the switch is on. If the switch is on, what happen? We will discuss in this mode. Look at here. If the switch is on, then what happen? If the switch is on, then look at here. This plus will be here and the minus will be here. What about this? This will be reverse bias. This will be off. So look at here. When the switch is on, there is no diode. And the inductor will observe the voltage, that is represents by VL with the sign of plus and minus. Capacitor will take the current, the inductor current will be represented with IL. Capacitor will take the current, name it as IC. Some I naught current V flows into the voltage V naught. This happens. First, mode 1. What is mode 1? Mode 1 means switch is on. Whenever the switch is on, automatically diode will become the off. Diode will become off. Yes. Here, if you observe here, the capacitor voltage, this capacitor and the output voltage both are connected in parallel. That's why the voltage across capacitor is nothing but output voltage. V0 is output voltage in steady state operation, but generally in transient it is different. But keep in mind it is in steady state operation. That's why both are connected in parallel. Right. So for example, we have to understand some points. Switch will be on for some time, switch will be off for some time. If it is on for some time, switch will be on for some time, on time, off will be off time. That is a switching, it defines the switching time. So just write this. That is, if the switch is on, then you will take it as T on period of switch. We can name it as the on period of switch. And sometimes switch will be off. We can name it as off period of switch. Off period of switch. Then total time period can be defined as on period as well as half period. Here always switching frequency is inversely proportional to the time period. We can name it as 1 by time period. And we can define a term is called the duty cycle. Term is called duty cycle. Duty cycle equal total on time period by total time. On time period by total time. The duty cycle is represents with the symbol of D. D for duty cycle, that represents on time by off time. Sorry, on time by total time. This is useful to understand the choppers. This is useful to understand the choppers. Okay, simple thing. Duty cycle is nothing but it is the ratio of on time to total time. It is a ratio of on time to total time. Okay, yeah. Now we will understand these points. These points are, look at here. So if you observe this diagram, this input voltage, if you apply the KVL, simply if you apply the KVL, then what happen? KVL means the current will be flows like this. These are parallel, means same current is flowing. Apply the KVL equal, this is plus and minus. By using the KVL we will get by KVL V input equal to voltage across inductor and output voltage. Voltage across inductor and the output voltage. Next, so from this we can write the inductor voltage. Inductor voltage is nothing but input voltage minus output voltage. What is inductor voltage? Inductor current L into dIL by dt into V input minus V output. From this I can write dIL by dt equal to V input minus V output by L. So I can modify DIL and DL, difference of IL, I can write like this: change in IL, DIL nothing but change in current, DT is nothing but change in time. So I can name it as the DT, difference of time, no problem, difference between time, that is V input minus V naught by L. So I can write like this: finally change in current, inductor current equal to V input V output by L into dt. So don't direct dt, just change in time. Change in time means on time period, that's why I am writing the dt. Since I can write change in load current will be equal to the change in time, nothing but on time. Change in time is nothing but the on time. Therefore finally switch will be on is nothing but the change in time or change in time. Okay, the finally therefore the change in load current when the switch is closed, we can write V input minus V naught by L into dt. This is the one equation. This is the one equation that represents like this. What is that equation? The equation is, the final equation is inductor current in when the switch is closed, change in inductor current equal to input voltage minus output voltage by inductance into dt. This is the first equation. Now we will discuss the mode 2 operation. In the second mode operation, look at here, the switch will be open. So in the second mode operation the switch is open, then diode will be on. Because by this plus voltage will be applied here. So you can observe here, the switch is on, then automatically plus and minus the diode will be on. Okay, in the second mode Second mode operation is simple, that is switch off and diode will be on. Diode will be on. So what happen when the supply is off? Inductor is acts as a source. So we can write here, when supply is off, energy stored in the inductor, energy stored in inductor is supplied to load resistance. So in the first mode, when the supply is connected to inductor will store the energy. Whenever supply is off, the stored energy in the inductor will be supplied to this load resistance. Then what happen? Now we can apply the same KVL here. Then we will understand. So if apply the KVL here, then just there is no voltage, you can take it as 0, and voltage stored in inductor VL, and the output voltage that you have to write here. Here we can write voltage equal to 0 equal to energy stored in the inductor, voltage is VL, and output voltage equal to V0. From this we can find out the VL value equal to minus V0. Understand? Again, what is VL? VL equal to L into DIL by dt equal to minus V0. From this we can write DIL by dt equal to minus V0 by L. Okay. So now we can define half time. So generally this is complete half period kada. This is about the switch half condition. This is the switch half period. What is the relation between on period and off period? Generally switch on period plus off period is equal to total period. From this we can find out the half period equal to total time minus on period. So generally half period, what is the relation between these two things? D into total time period. So from this T off equal to 1 minus D into T. So this is the relation between half period and on period. The half period equal to 1 minus duty ratio into total time period. From this I can write this here. Change in IL means DIL. The dt is time, 1 minus D into T, change in current, equal to minus del V0 by L. Okay. From this I can write, from that equation I will find out when change in inductor current when switch is off. These all are in off position. We are discussing about the off position. So we will get the equation as minus V naught by L into 1 minus D into T. This is the second equation. This is the different. This is the second equation. This is the second equation. First equation, the change in inductor current when the switch is closed. This is the first equation. Second equation is change in inductor current when the switch is off. This is the second equation. So by using these two equations, generally the inductor in a cycle, the net charge in a inductor is 0. Net energy stored in the inductor is 0. So just write down that point. That point is net charge of inductor over any complete cycle is 0. Over any complete cycle is 0. So generally complete cycle means we are on the switch and off switch, that is T. Total time period is called as the complete cycle. Is called as the complete cycle. So that's why I can write is in the complete cycle the total charge is 0. Total charge is 0 means change in inductor current when the switch is closed plus change in inductor current when the switch is open is equal to 0. Sorry. From this I can write when the switch is closed means on condition, I can write V input minus V naught into D into T by L plus minus V naught by L 1 minus dt is equals to 0. So by simplifying it, we will finally get, that is V naught by V input equal to D. V naught by V input equal D. What is V naught here? R, the output voltage equal to D times of input voltage. The output voltage equal to D times of input voltage. Okay. What is V? V input voltage, relation between input voltage, the input or supply voltage, and V naught equal to output voltage and D equal to duty ratio. Duty cycle or duty ratio. What is the relation between duty ratio? Duty ratio equal to on time period by total time. So finally we will get, for step down chopper or buck to buck converter, this is the relation. So finally we will find this relation. Understand? So by using the buck converter or DC to DC buck converter or step down chopper, we will get the final relation between output voltage and input voltage is like this. Output voltage by input voltage equal to D, or output voltage equal to D times of input voltage. So this is about the DC to DC buck converter. Okay, thank you. Hello students, these are the waveforms related to our DC buck converters. The first is this is related to the input voltage. This is related to the input voltage. Look at here. This is on time period. That's why it is represents with DTS, and remaining is the off time. This is the on time, this is the off time. We can name it as the source voltage, maximum source voltage, and off time, on time. We have more number of cycles, depends on this. In this, the inductor current, it is at minimum position for on time period, it will be increases to maximum. Whenever it is off time, it will be minimum, maximum, minimum, maximum, minimum, like this. This is the change in inductor current. This is change in inductor current. In the first case, we write the equation for this thing, and the second case we write the equation for this thing, and this will be repeated like this. Next, this is the inductor current. Capacitor current IC. The IC current equaled from negative point to it will reach the maximum point for on time period, and for off time period it will be decreases. So it will be continuous. And this is the inductor voltage. For on time period the complete voltage will be like this. For off time period this will be negative. This will be positive and this will be negative, like this. Finally we have to write the output voltage. The output voltage waveform is missed here. We can write this output voltage is follows like this. The output voltage is and like this, slightly increases and decreases. So this is the on time period. We can take it as the on time period, and this is the half time period. This is the output voltage of the DC-DC buck converter. So in your examination you have to draw this. Next, we will discuss a problem related this, then we will understand very clearly. And the problem is, a buck converter input voltage is 100 volts. First is given the input voltage, that is 100 volts, and on time period is 10 millisecond. He is given on time period, and total time period T equal to 20 millisecond. And what is the magnitude of output voltage? So for buck converter output voltage equal to duty cycle into total duty cycle into input voltage. What is duty cycle? Duty cycle D equal to on time period by total time. The on time period total time means on time as well as off, we know that. So on time period is given 10 millisecond, and half total time is 20 millisecond. By doing this we will get 2. So duty cycle we will get D value is 1 by 2. Then the output voltage equal to D into input voltage. D into 1 by 2, the input voltage is 100. By doing this 50 volts. Therefore the output voltage equal to 50 volts. What is duty ratio? Duty ratio is 0.5. Whenever duty ratio is 0.5, automatically output voltage will be decreases. So this is the procedure to do the any problem related to the buck converter. Understand? Right. So simply use this formula. Thank you.